Hello students, I am Kausalya. Today we are going to solve this problem, that is determine the transfer function y2 of s by f of s of the system shown below. So here this is the given problem, and this problem consists of two masses, namely m1 and m2. Here they have directly asked to find the transfer function y2 of s by f of s. So let us see what are all the things given in the problem. So here the force f of t is applied to m1 and the respective displacement is y1. Similarly, because of this force f of t, m2 will also get displaced. So the respective displacement of m2 is here y2. Now I am going to draw the free body diagram of mass m1. So as I already said, the previous problem, the same way we are going to solve this one also. So here in this case, just consider this mass m1. Here to this mass m1, just count the number of elements which are connected to mass m1. So here in this case, we are having a spring k1, a dashpot b, and another spring k2. So this is the rough diagram I have drawn from the given problem. So this is m1, and to this m1 we are having k1b and k2. Right. Now I am going to write the force balance equation of this mass m1. So here in this case, to this mass m1 we are also having an applied force f of t. Right. So in the free body diagram, let f of t be this direction. So automatically the opposing forces are provided by k1, k2, b and m1 also. So totally there will be 4 opposing forces. So the first opposing force will be provided by the mass m1, and the second force be fk1, and third force be fb, and the last force be f of k2. Okay, I hope from this diagram it will be clear to you. So 1, 2, 3, and this is the applied force 4, and apart from that there will be another opposing force provided by this mass m1. So totally 5 forces are acting on mass m1. So 1, 2, 3, 4, 5. Right. So again by Newton's second law, so the applied force is f of t, which is equal to your opposing forces, that will be fm1, fk1, fb plus fk2. Now I am going to write force balance equations for each and individual term. So fm1, so the opposition force produced by mass m1 will be directly proportional to its acceleration. So here the respective displacement of mass m1 is given as y1. So Fm is directly proportional to d square y1 by dt square. So which is equal to m1 into d square y1 by dt square. Next one is fk1. So here fk1 is directly proportional to the displacement y1. So fk1 is directly proportional to y1, which is equal to k1 into y1. And the next one is fb. So fb is directly proportional to dy1 by dt. So here when you insert proportionality constant, this becomes b into dy1 by dt. And the last one is here k2. This k2 is connected between m1 and m2. But now we are drawing the free body diagram of mass m1. So while writing displacement, it should be written as k2 is directly proportional to the displacement of mass m1 is y1. So you have to write y1 minus of y2. So when you insert this proportionality constant, this becomes k2 into y1 minus y2. And next one is I am going to substitute these values in the above expression. So this expression becomes f of t is equal to m1 into d square y1 by dt square plus k1 into y1, and again b into dy1 by dt plus k2 into y1 minus y2. Okay, this is the force balance equation of the mass m1. And next thing is I am going to take Laplace transformation for this equation. So when you take Laplace transformation, this expression will get modified as, actually let me do this Laplace transformation in a fresh page. So this equation will be right. So when you take Laplace transformation, the force f of t will become f of s. So f of s is equal to m1 into s square of y1 of s plus k1 into y1 of s plus b into s into y1 of s, and again this equation will become k2 into y1 of s minus y2 of s, right. So here in this case again just I am taking the common terms outside, that is this expression contains y1 of s and here and here. So just I am taking y1 of s commonly outside. So when you take y1 of s from this expression, the remaining term will be m1 into s square. So just write as such m1 s square. So from here it will be k1, and from here this becomes ks, and from here this becomes k2. Right, and the remaining term will be k2 into minus y2 of s. So minus k2 into y2 of s. This is your expression f of s. Okay, now your expression f of s gets modified like this. So just name it as equation number 1. And next I am going to draw the free body diagram of mass m2. So here this is your mass m2, and just from the problem I have written this. So to this mass m2 we are having only one element which is connected here. So now the free body diagram of mass m2 is, this m2 will provide one opposition force, so that I am writing it as f m2, and the another opposition force will be provided by k2. So here I am writing it as f k2. There is no applied force on this mass m2 directly. That is, from this problem it is clear that the applied force is only on mass m1 and no applied force is on mass m2. So in the free body diagram of mass m2 there is no applied force. So now I am going to write the force balance equation. So again by Newton's law, here the applied force is 0. So the opposing force is nothing but fm2 and fk2. So while writing expression for fm2 is directly proportional to the d square, and here the respective displacement is, it is given as y2. So d square y2 by dt square, and when you insert proportionality constant, this expression becomes m2 into d square y2 by dt square. And again here this is fk2, and fk2 is directly proportional to, again you see this k2 is connected between m1 and m2, and now we are considering only m2. So while writing the expression, the respective displacement of m2 is y2, and this should come first. So it is directly proportional to y2 minus y1. So when you insert proportionality constant, this becomes k2 into y2 minus y1, and this is your expression for fk2. Just substitute these values in the above expression. So we will be getting 0 equal to m2 into d square y2 by dt square plus k2 into y2 minus y1. Again when you take Laplace transformation, this expression will become m2 into s square into y2 of s plus k2 into y2 of s minus y1 of s. So just again rearrange the terms. When you take y2 of s commonly outside, the remaining term will be m2 s square plus k2, and again minus k2 into y1 of s, and this is equal to 0. So here in this case just I am rearranging this expression. So when you bring this minus k2 y1 of s to this side, that becomes positive. So k2 into y1 of s is equal to y2 of s into m2 s square plus k2. So now y1 of s can be written as y2 of s into m2 s square plus k2 divided by k2. Okay, now name this expression as number 2. Now what is the transfer function they are asking is, we are asked to find y2 of s by f of s, right? Now I am going to substitute this expression y1 of s, that is this equation number 2 in equation number 1. So when I substitute this equation, the equation number 1 gets modified as, so instead of y1 of s, I am going to substitute in terms of y2 of s. We are getting this expression from equation number 2. So this becomes this equation becomes y2 of s into, instead of y1 of s, I have substituted this expression and the remaining terms remains as such. So this becomes m1 s square plus k1 plus k2 plus bs, and this minus k2 into y2 of s. So here in this case, just take, here also you are having y2 of s and here also y2 of s. So just take y2 of s commonly outside. So when you take y2 of s commonly outside, the remaining terms will be m2 s square plus k2, m1 s square plus k1 plus k2 plus bs divided by k2, here again minus k2. So when you take LCM for this expression gets reduced to m2 s square plus k2, m1 s square plus k1 plus k2 plus bs minus k2 into k2 becomes k2 square, and this entire expression will be divided by k2, right? So now we are asked to find the expression y2 of s by f of s. So here just I am rearranging. We are having f of s and y2 of s. What we need is y2 of s by f of s. So here in this expression, y2 of s by f of s, so k2 divided by, right, I need y2 of s by f of s. So I am moving this f of s to the denominator term, and here this entire expression will go that side as a reciprocal. So k2 divided by m2 s square plus k2 into m1 s square plus k1 plus k2 plus bs minus k2 square. So this is the transfer function which we need finally. So that's all. The problem is over. Thank you.